Hello, my name's Max. You're going to see a lot more of me today. Yes, in the following film entitled Why? About the repair of safety valves. Safety valves are often installed in places where environmental conditions are not particularly friendly. They can be due either to an aggressive production-dependent ambient atmosphere on the one hand, or to a natural one, which persistently attacks the surfaces of the safety valve components from outside. On the other hand, the actual medium or its accompanying products can affect the interior of the safety valve by subjecting it to chemical and mechanical stresses. Not only these influences, but also wear and tear and operationally induced mechanical stress are finally the reason why, at certain specified intervals, safety valves have to find their way to the repair shop for maintenance or repair. By that time, they are often outwardly already in a very dismal state of repair, which doesn't mean, however, that their smooth function is in any way impaired. When you consider that a safety valve consists of anything up to 80 individual parts, it's amazing how robustly constructed such an instrument can altogether be. With one exception: the delicate sealing surfaces. Less frequently, the defects are found in the areas of the spring, the spindle, and the spindle guide. But a safety valve that no longer opens cannot be ruled out altogether. Sometimes this is the result of inexpert handling or so-called repairs by non-qualified persons. But this mustn't necessarily lead to such sheer monstrosities as this safety valve from our cabinet of curiosities. Here the spring clamped to a block and the upper side of the spindle are positioned in the inlet flange, while the disc is projecting freely into the bonnet. The customer wrote that this valve could no longer be induced to provide a tight seal, a hazardous manipulation whose consequences might have been very far-reaching indeed. Back to repair frequency. Most safety valves are put in for repair because they are leaky. They allow medium to escape, although the set pressure has not yet been attained. Either from the causes already mentioned or through contaminated media or valve vibration, the sensitive metallic sealing surfaces or the soft seal can be damaged, allowing media to escape continually between the disc and the seat, so that in this way money literally goes down the drain. Let's look at one of these repair procedures in more detail. First, make sure that the lead seal is undamaged and whether unauthorized tampering has taken place. In the case of a missing or damaged seal, exercise great caution in subsequent evaluation. The cap, H2, can, after removal of the lead seal, be unscrewed with the appropriate wrench. With lifting gear H3, first remove the retaining clip and pin of the lever, and then pull out the lever sideways. Now loosen the retaining screw and then unscrew and remove the lever cover. With a lifting gear H4, the lever is pressed to its end point so that the lifting fork is disengaged from the spindle cap. Then the lever cover can be unscrewed. We then tap the splined pin out of the spindle cap and can then remove this from the spindle. Before the adjusting screw can be turned, the lock nut must first be slackened. When turning the adjusting screw, be very careful that the spindle doesn't turn with it. Why? So that the disc doesn't turn on the seat and either initially or still further damage the highly sensitive sealing surfaces. The adjusting screw has to be slackened far enough for the spring tension to be released altogether before the hex nuts are unscrewed from the flange of the bonnet. Why? First, the bonnet would tilt under spring tension as the hex nuts are released in succession, and this unilateral loading of the disc and seat would damage the sealing surfaces. Secondly, a bonnet released suddenly under spring tension could act like a dangerous projectile. So only release and remove the bonnet when the spring tension has been relaxed. Some types of spring have residual tension even when the adjusting screw has been entirely released. A sign of this is that 2 of the 4 bonnet studs are longer than the others. When the bonnet is closed, one must always be prepared for medium having escaped into the bonnet chamber. That is why industrial gloves and protective goggles are absolutely mandatory, even when releasing the bonnet nuts, if the medium that the safety valve was securing is not known. After removing the bonnet, the upper spring plate can be slid off the spindle. Now, first the spring, then the lower spring plate, and finally the spindle, complete with spindle guide and disc, can be removed. The valve has now been almost completely dismantled, and all the component parts can be assessed individually. This lifting aid has been completely eroded by high-pressure water. The plant was run too close to the set pressure of the safety valve so that the valve disc was constantly floating. This seat's surface was destroyed by plant condition vibration of the valve. Bellows destroyed by turning the adjusting screw without securing the spindle against co-movement. This outlet flange broke off because a blow-off pipe of considerable weight was attached to it. Before this, the safety valve had started to leak on account of the high mechanical stress imposed upon it. Safety valves are not structural elements. They must be mounted free of mechanical stress. Condensate in combination with atmospheric oxygen have completely destroyed the bonnet, disc and spindle of this valve from the reverse side. Why? Because the plant was wrongly planned. A safety valve outlet should never be connected directly to a rising pipe because dirt and condensate could collect there and damage the inside of the valve. A length of falling pipe should be connected first, and at its lowermost point a drain is installed to ensure that the condensate is taken off completely. The soft seal on this disc in a heating valve was destroyed by welding globules and sand residues in the heating water, a not uncommon source of trouble in new systems. The resistance to chemical and temperature influences is still a limiting factor with soft seal materials today. That is why it is particularly important to observe the LESER Works Standards 319, materials for elastomers soft seal discs, when selecting the sealing material. This safety valve defied all attempts at dismantling and had to be cut open to ascertain the cause of malfunction: hardened cement grout. Was this valve vented at regular intervals as specified? In the case of valves with closed bonnet, incorrect mounting of the blow-off pipe can cause condensate to accumulate in the bonnet and damage the spring. Here the casting itself is satisfactory. The corroded housing can be sandblasted and then reused. If the seat and disc are only slightly damaged, the seating surfaces can be repolished manually. If repolishing is not sufficient, the seat can be returned. In this case, the design measurements and contours should be observed so that, for example, when regrinding seats, the body of the valve is returned to exactly the same proportions. As an emergency measure, it is practical simply to grind the seat and the disc against one another. A good recommendation is to make use of a lapping stick, obtainable from LESER. When repolishing a disc by hand, it is advisable to position the lapping stick below and the disc above, so that the lapping paste doesn't creep too far between the disc and the lifting aid. Any remaining lapping paste must be carefully removed after the lapping operation. The main difficulty in hand lapping is, by the way, keeping the seating surface flat. That's why it's best to make short, identical circular movements. Don't exert any pressure on the lapping stick. Let it operate under its own gravity and only for short periods. To enable discs to be reconditioned by machine lapping or on a lapping stone, the detachable lifting aid was developed for removal in such cases. Parts which cannot be reconditioned have to be replaced by new ones. To do so, the disc is released from the spindle, as seen here. Reassembly is the subject of Part C. Here a new disc is being assembled to the spindle, whereby the ball must not be forgotten. Why? The ball brings the spring force to bear exactly in the center of the disc, and via this ball pivot it is distributed evenly over the sealing surfaces. To tap in the pin, it's best to make use of a firm lateral support. After sliding the spindle guide over the spindle, test for free working. If the guide does not allow the spindle to move freely up and down in spite of the spindle being in perfect condition, it is advisable to replace the spindle guide. Now the two halves of the split ring are placed in the groove on the spindle, the securing ring is pressed on top of it, and the lower spring plate is pushed over it. If the split ring is forgotten, pressure adjustment is not possible. Why? The spring plate would drop down as far as the spindle guide, and the spring tension would not be transmitted to the spindle, and hence the disc. Take a soft, clean cloth to carefully wipe the seat and disc again. Place the gasket in the packing strip, and then, carefully, introduce the spindle with the disc and spindle guide into the body of the valve. Check the spring for perpendicularity once again. Why? Because if the spring is not perpendicular, it will tilt and later impair the response precision of the safety valve. First, check the spring number against the data in the spring table. Now we slide the spring and the spring plate over the spindle, then lay the washer for the adjusting screw on the upper spring plate. The adjusting screw, like all threaded elements, is greased before being screwed into the bonnet. Then we fit the bonnet to the body, whereby the spindle is carefully guided through the adjusting screw. The bonnet nuts must be tightened evenly. Why? To avoid tilting the bonnet and causing inadmissible friction in the guideways. Now the spring can be loaded by turning the adjusting screw in a clockwise direction. The sealing surfaces of this safety valve have been severely damaged. Remember, ensure that the spindle does not rotate too. This is the right way. To relax the torsion on the spring caused by the adjustment, the setting procedure should always end with a slight unscrewing of the adjusting screw. In the case of greater forces acting on the valve, instead of the washers under the adjusting screw, we can install a ball bearing to LESER Works Standard 065. To complete the setting, the lock nut must be tightened to prevent any unforeseen changes in the set pressure occurring later. The safety valve must respond 3 times at exactly the required set pressure. Then the pressure is reduced by 10% and the valve must not leak at this pressure. As a rough test, we can observe on the manometer whether the pressure remains constant or drops. This valve would fail to pass even this initial test, but if the pressure remains constant, its seal is considered to be satisfactory. This is followed by a more exacting test with the leak detection fluid NECAL. A NECAL bubble is stretched over the outlet and observed until it ruptures through evaporation. During this time, the film surface shouldn't bulge more than at the start. Another method of conducting a leakage test is to count the number of bubbles per minute. Finally, depending on the configuration, screw on the cap H2, whereby the position of the cap can be corrected with the aid of a spacer, or reposition the spindle cap on top of the spindle. In older models, the cap is fixed by means of a splined pin. To prevent damage to the sensitive sealing surfaces and the guideways of the valve, it can only be tapped with very light hammer blows, which have to be absorbed by holding another hammerhead or a piece of solid metal against it. To avoid this hammering, later valve configurations make use of a dowel pin, which is placed in position by hand and secured with a spring, which is slid over the spindle before replacing the spindle cap. Now screw on the lever cover H3. The lever should be 180 degrees diametrically opposite to the outlet opening. In this position, the lever cover is secured with the retaining screw. Now insert the lever through the window and guide it under the collar of the spindle cap. The lever can only be assembled with a pin secured by a retaining clip. To replace the lifting gear H4 in the required position, spacers are used. When screwing on the lifting gear, the lever has to be held to its end point to ensure that the lifting fork disengages from the spindle cap. Test the lifting gear afterwards to ascertain whether it has been correctly reassembled. Attention, lifting must be possible by manual force alone. At higher set pressures, therefore, at least 85% of the blow-off pressure should come to bear on the disc. Otherwise, one would be trying to lift against the full spring power. In the case of gas-tight valves, the bonnet and the connections must be tested for leakage. The same applies to the cap, H2. To do so, the valve is fixed to the test bench by the outlet flange to allow pressure to build up from the opposite side. The leak detection fluid is applied to the surfaces to see whether bubbles occur. To secure the safety valve against alteration of the set pressure, a wired lead seal is applied between the cap and the bonnet. When the set pressure is approved by the TUV or any other inspection authority, the seal of the appropriate organization is applied. The completed type approval plate documents the technical data of each valve. If the set pressure is changed, the pressure value cast on the edge of the flange must be ground out and replaced by the new value. In every case, the fitter's sign, as well as the month and year of repair or conversion, must be stamped in. The manufacturer cannot accept any responsibility in the event of a damaged lead seal or other alterations to the valve by third parties. It's therefore advisable to carry out necessary adjustments only at the factory or in workshops authorized by the manufacturer. Plastic caps on the inlet and outlet protect the interior of the valve from damage and dirt during transportation to its destination. When alterations have to be made to the set pressure, please consult the table to see whether the coefficient of discharge is changed. If a new value results, this has to be noted on the type approval plate and the previous value deleted. If the type test approval has no validity for the revised value, a simple LESER type plate must be affixed. The admissible pressure range of a spring should be checked during every alteration of set pressure by comparing the spring number with the data in the spring table. Why? Although it is possible to set a higher or lower pressure than the table allows for a given spring, the function of the valve is negatively influenced in such cases. For example, the spring can block before the full lift is attained. As this occurrence may not be noticed, particularly in the case of valves with closed bonnet, it could lead, in extreme cases, to discharge capacities falling well short of the specified mass flow, thus provoking disaster. But you can get a nasty surprise as the result of careless painting or spraying, when paint penetrates between the moving parts and, as here, gets into the open bonnet, and from there between the spindle and the spindle guide. Not like this. Practical tests have shown that a safety valve misused in this way still does not open at many times the set pressure. But unqualified installation can also impair the performance of a safety valve. Safety valves should therefore only be installed with the bonnet vertically upwards. This is the only way to guarantee that the valve blows off at the precise set pressure, reaches its full discharge capacity, and above all, closes again as required. The full mass flow can only be achieved if the cross-sections of the inlet and outlet are not narrowed in any way during installation, as for instance here with a slipped gasket. A 100% obstruction of the pipe cross-section has been known to occur because the fitter forgot to remove the protective cap before installing the valve. Safety valves should never be carried by the lifting gear. Why? Because of the danger, especially at low set pressure, of the disc hitting against the seat and thus damaging the delicate sealing surfaces. For this reason, safety devices are installed in the factory to prevent transportation damage. The wire securing the lever to the bonnet of a spring-loaded safety valve is to be removed only after installation. Finally, safety valves have to be manually lifted at specified inspection intervals. The cross-sections of the threaded connections should never be narrowed, for example by the use of hemp or PTFE tape for leak-proofing. Such materials are among the most common causes of valve failure because particles of the packing material break off while the screw connection is being made and find their way inside the body of the valve where they're deposited between the disc and the seat. Only metal seal washers should be used for these valves. To align the connections, spacers of various thicknesses can be selected. Safety valves for the medium of oxygen are specially factory cleaned of oil and degreased, then sealed in foil and protected against moisture with cicative powder. But if they are touched with the naked hand at some later date, these specifications are of course no longer valid. And for lubrication, only special agents such as halocarbon should be applied. Repairs to these safety valves should therefore only be carried out by the manufacturer. Even the smallest alterations to the manufacturer's specifications respecting safety valves can affect the opening and closing characteristics and influence the performance curve. Only when a safety valve in this respect precisely conforms to the technical regulations and its behavior can be defined in terms of a type test does it receive the TÜV approval sign appropriate to the given valve type. That is a very cogent reason why the manufacturer can accept no responsibility for the functional efficiency of a valve on which the lead seal has been broken by the operator or by third parties. The way to the authorized repair shop or back to the manufacturer is the only guarantee that this vital appliance will, after repair, continue to be what its name implies: a safety valve. Thank you for your kind attention and auf Wiedersehen.